Hello and welcome back to Cracking the Cryptic on Friday the 13th of November. And indeed we will be using that date as the theme for this puzzle. Now, just before that, I will first of all mention things going on obviously the Kickstarter's into its last 3 days. Do get over there if you've been considering it and pledge to reserve yourself a book. Thank you very much to all those who have already, I believe, made this the second biggest puzzle product on Kickstarter ever, which is unbelievable. Thank you. Loads going on though on the channel and Patreon. Crossword content a go-go at the moment. Simon's done Dave Gorman's puzzle. Later in the week I'll show you a listener solve that I did a few weeks ago, and also my practice for the Times Online Crossword Championship continues. So 2 videos on that already, a third to come at least, and maybe more. And we have 2 videos coming up on Patreon from Sam Cappleman-Lynes on his brutal but brilliant puzzle that was the subject of our competition. And then we'll put up a video on the November monthly reward puzzles, which were a bit easier, but not still easy. And that brings us on to today's puzzle. Now, Friday the 13th has led Lichtes, sorry if I'm pronouncing that wrong, to create an unlucky killer Sudoku. And now this has been published on Logic Masters Germany, and Simon tells me there are 2 rule sets, one easier, one harder. You can guess which he has made me do. So I get the harder version, which is actually just plain killer Sudoku. So 2 givens that look like 13. All the given cage totals are 13. Cages cannot contain repeated numbers. Regular killer stuff. So going to have a go at that. Just before I start, I know Simon mentioned the Masters Golf yesterday. I am, in honour of that, wearing the shirt I got from the Ryder Cup, which Simon and I visited together 14 years ago in 2006. And actually, he texted me yesterday before they began play in America and said he'd seen that Tiger Woods was at 35 to 1 and he thought the odds were ridiculous. I knew what would annoy him the most, so I texted him back that the odds seemed fair to me, and he just like, okay, whatever, was the text back. But we then discussed it, and in fact I managed to back Tiger with £5 at 65 to 1. So do cheer him on, although by the time you watch this, his round will be over for the second round, and that bet will either be dead in the water or still surprisingly alive. And either way, never take your sports betting advice from Sudoku players. They are not experts. And on to the puzzle. Do try it on the link below the video, but I'm going to have a go now. Let's get cracking. How do we get cracking with this? Right, column 3 has 3 2-cell 13 cages. So either by maths, by adding them up and deducting from 45, or by just asking where do 1 and 2 go in the column, you can see they must go here. And 3 in box 7 must be in one of those 2 cells, because 1, 2 and 3 are all too small to be in these 2-cell cages that add to 13. Ah, yes, where do 1 and 2 go in row 7? That's a nice question. Again, they can't be in the 13 cages, and now they can't be in this box, so they must be in those 2 cells. I think there are only 2 4-cell 13 cages in the puzzle. And there are only 3 combinations for that. It's either 1, 2, 3, 7, 1, 2, 4, 6, or 1, 3, 4, 5, which actually means that 1 is used in both of those marked areas. So 1 in column 6 is going to be somewhere here. Lovely. Yes, look, there are 2 13 cages flanking this pair, so they can't be 4, 6, or these couldn't be 4, 9 or 6, 7. They'd both have to be 5, 8, which is ludicrous. So let's put in 3, 7 there. And what does that tell us? This can't have a 7 in now, so it can't have a 6 in either. It's 4, 5, 8 on 4 and 9, or 5 and 8. 6 must be in one of these cells because it can't be here because that would put a 7 here. It could be here with a 7 here or here, which doesn't tell us anything. And maybe it... No. What can we do now? These add up to 26, 29, 30. So these two add up to 15. So they're either 6, 9 or 7, 8. This must be 4, 5, 6 or 7 to make up the sum to 13. There's so many 2-cell 13 cages. What? These must be from 4, 5, 8 or 9 as well, because they're in the same row as the 7. So these have to be 1, 2 or 6, because that makes a 4, 5, 8, 9 quadruple. 6 there would put 4 and 3 here, or 5 and 2. Oh, that's interesting. These two cages are pointing at this one, by which I mean, if they were, say, 4, 9 and 5, 8, that cell would have to be part of a 6, 7. Yes, I think this is going to be important. There are 3 types of 2-cell cage available here: 4, 9, 5, 8 and 6, 7. And let's colour them. Let's colour them green and orange and blue. And why I'm doing those different is I know these all have to be different. These two, because they're in the same row, but they're both looking at this one. So wherever they look at a cage in a row or column that's on the perpendicular, that has to be different too. So these two are green and orange, and that makes this one blue as well, because they both have 2 cells in a box with 1 cell of that cage. That makes this cell effectively blue, because there's 2 blue cells already there. And in fact, that now can't be the 3, so I can put the 3 in here. It's a digit in the grid. Feels like a minor triumph in this puzzle. I don't know which of those is green and which is orange. Now, that is looking at both that and that. So again, those two have to be different, obviously. And that is also looking at that. Oh, but that could be blue. I was going to say they have to be different. Oh, I don't know. Oh, that's interesting. I'm starting to wonder if these two have to be the same. And I think they do. No, look, the simpler way of looking at it is that the same as this? Yes, and the answer is no. Why is this not orange? Because where would you put the 2 orange cells in this row, in row 8? Well, they'd have to be in these 3 cells. Obviously 3 wouldn't be one of them, so 7 would be one, but the other has to be 6 then, so they can't fit in there. So that's not orange. This is orange. This is orange now for a very similar reason. Whatever those 2 digits are the same as those 2, and they must both be in those 3 cells. So one of them must get into the 13 cage, and in fact that means both of them do. So orange is always 4, 9 or 5, 8. Does this have to be blue? I think it does, but probably not for a logical reason at the moment, but more for a uniqueness reason. If that was green, in theory, you could have, say, 9, 4 there and 4, 9 there, but in practice, you couldn't have a unique solution to the puzzle. But I don't want to use that yet, really, if I can avoid it. Oh, look, 12, yes. That's interesting. There are 5 cages in these 2 boxes which have to add up to 90. The 5 cages are all... No, there are 6 cages. They add up to 78, 13 times 6. So these 3 cells add up to 12. Oh, look, if you put a 6 here, this is brilliant. If you were to put a 6 here, you can't put a 6 here because then these 3 can't add up to 12. But you could put a 1 or a 2 there, but that would give you a 4 or a 5 here. And if you've put a 6 here and a 4 or 5 here, how are you going to fill those 2 cages? You can't do it, not both of them. You could fill either one of them, but one of them, if there's a 6 there, one of them needs a 4 and one of them needs a 5. So there is not a 6 there. That is not 4 and 5 as a possibilities. The 6 now has to be here, and we know what green is. Ha ha. Okay, that's nice. Well, don't tell me this is just going to peter out here. Well, I suppose blue is not 6, 7. So blue is 4, 5, 8 or 9. We can do the same there. This must be 6 or 7 and is green as well. I could probably have coloured that before. Yes, I could. This is not 6 or 7 now. Now that means this cell is 6 or 7. I'm going to colour it green. It's not part of a cage, but at least I know where the greens are going. And these are 2 and orange, but I don't know which one is orange. And that may be beyond my colouring ability. 2 is definitely in this set, because it's not anywhere else in the box. 2 there, 2 there, and 2 there. Yeah, I mean, that's Sudoku logic anyway. Now, this can't be the 6, 7 cage, so it's not green, because that is 6 or 7. So it is orange. This is green. That is looked at by this, but that could be orange or blue. This, however, is looking at both orange and blue, so that's green. These 2 must be orange and blue. Oh, that's also looking at this, which is looking at that. That has to be blue. This can't be blue now. So, and it can't be green because it's got a cell there. So that's orange. This is blue. Oh, this is brilliant. I wasn't sure when I began colouring if that's the way to attack this puzzle. I am sure now. This is lovely. Can I do these last 2? 3 cages, 3 2-cell cages. This sees green, but it could be orange or blue. I don't see... That's not blue, but it can be green or orange, and that's not orange, but it can be green or blue. So I don't see how to resolve those yet, which is annoying. Can I use those ones? No, I'm going to have to do something else. Right, that is 4, 5, 8 or 9, and the whole set is formed there. So those are orange. These ones are basically blue. I might as well colour them. Ah, and that's blue as well. Oh, and that is interesting now, because those 2 blues are looking at these 2 cages, so they can't be blue. This one can't be blue or green that it's looking at over there, so it's orange. And that means this can't be orange because all the orange cells for columns 6 and 7 have been used up, so that's green. And we know that, sorry, I should have been filling these in. We know that greens are 7 and 6. I was right to make those blue. Yes, once that was orange, they were blue. Yes, okay, so I may have been slow to identify that, but I got there. 7 and 6 up there. My goodness, this is extraordinary, this puzzle. But I don't know yet what makes up blue and orange. Right, this was going to be 1, 2, 3, 7, 1, 2, 4, 6. They're both gone, so it's 1, 3, 4, 5. We get 2, 8, 9 in this group of cells. Obviously the one in the 13 cage can't be a 2. Still don't know what that means orange is. One, 3, 4, 6 and 7. That's 7's resolved this 3, 7 pair. Is that any help? That's not a 3. 2's in one of those two cells. I don't know what that means. These are from 4, 5, 8 and 9. Now the 2 up here goes with either 6 or 7, not in that cell. And a blue, the blue one. Yeah, that's interesting. In this 13 cage, the 3 cell cage, the 2 goes with a green number, 6 or 7, and a blue number, 8 or 9. Now, that's not initially helpful because you don't know which way round they go. It could be 6, 9 or 7, 8. But what am I talking about? That's far too many. No, it does go with a green and a blue number, but it's 6, 7 and 4 or 5. You don't know which way round because they make an odd number either way, 11 either way. Yeah, but weirdly, you do know where the blue cell goes because of those 2 blues in row 3 and those 2 in row 1. So the blue cell is there. The green cell is not here because the 2 greens done there already. The green cell is there. So that is 6 or 7, not 2. The 2 must be down here in an uncoloured cell. That is 4 or 5 there. How does that 2 help? I'm proud of that deduction. 2 has to be up here somewhere with 6 or 7. So 2 is along here. I don't know. This 13 doesn't contain a 2, but there are still several possibilities with 3 possibilities with a 1 and 3, 4, 6, I think, all work. It'd be nice to know now what blue and orange, what their constituents are. Can that be a 9? Yes, with 1 and 3. Or even the other way around. These are all from 4, 5, 8 and 9. Come on, it was going so well. Let's keep finding something. That's 4 or 5, so that's 8 or 9 there, which means that one is 4 or 5, which means that one is 8 or 9. That's probably not getting anything done. I could have done that the other way around from that one. It's 13, and 13 is 26. These 2 add up to 13 as well, so that's 39. These 2 therefore add up to 6. So we can forget 8 and 9 there, and indeed 4, because that can't be a 2. And this can't be... It could be 4. We don't know where the 2 orange cells go here. Although... Actually, where do the 2 orange cells go? Not there, because there's 2 orange cells in row 5. They can't both go there, because that would be 3 in the column. So that is an orange cell. And that tells us, well, it tells us it's not 2. And actually now, where does 2 go in the box? It goes here. Wow, that's weird. Okay, 2, 4 there. And that means this cell is 5, and we know that blue is 5 and 8. Hooray! Blue is 5 and 8. Blue is 5 and 8. Keep doing 5s and 8s in the blue. 8, 5. Can't decide these, but we can take 4 and 9 out. Right. So, blue is 5 and 8. Green is 6 and 7. Obviously, orange is 4 and 9. So, let's start by removing the 5s and 8s. And here we can actually fill in 9 and 4 now. That's not a 9. Nor's that. Those are not 5 and 4. So in fact we can complete 1 and 3. We can do that whole box. 1, 3, 5, 4. 5, 8, 6, 7. That is a 4. Oh yes, some of these 4 and 9s may be done that I hadn't noticed. No, only those two. This 13 cage, 2 and 5 is 7. That's a 6. 7 there, so not a 6 up here. 2, 7 pair. Now, we've got 1, 4, 3 and 6. That must be a 3, 4, 6 cage. So we get a 1 in that cell. This is not a 1. That's a 1. This is 2 or 3 by Sudoku. So this is a 2, 3, 8 cage. Must be, I think, with those possible constituents in it. Yeah, they make 13, so 3 must be there, and a 2, 8 pair below. These are from 6, 7 and 9. 2 and 9 up here. Actually, still don't know which way round they go. But that 8, 5 has been determined. That 1, 2, surely we can finish all these off. Yes, 9, 4, now we can do 2, 9. Oops, 2, 9. That puts an 8 in the central cell. This 4 or 9 is given now. This 6 and 7 can be done. Look, it's all coming together now. It's a very beautiful puzzle, but I don't think that was easy at all. I mean, I'm not finished, but what has been done has not been easy. 2, 7, 3, 4, 6. That's a 4 now. 4 there. 4 and 9 there. 5, 8 pair there. So that does sort that out. Actually, it was the last number in the box. So I'm still going to have to do this. Oh, and this 13 cage. 6, 7, 9, 4, 5, 8. Sorry, I just need to concentrate now. 12, 25. Oh, 9 and 9. So 9 is up here. So 9's not in this. It's made up of 6, 5, 7, 6, 5, 3, 1 minus 2 of those digits, which is 22 minus 9. So 6 and 3 are not in it. It's a 5, 7, 1 cage. 5 goes there. 5 with a 1, 7 pair there, which sorts out everything else in that row. So 7's not here. That's 6, 9, 2 and 3 to go in down here. That 4 and 9 has been resolved. It must be straightforward now. Right, another 13 to go in here. Oh, these 3 were going to add up to 12, weren't they? That was one of our vital stepping stones earlier on. 8, 1, 3 would do it, or 5. Ooh, various possibilities. Okay, let's have a look at this 13 cage instead then. 7, 9, 4. So 13, 20. We've got 25 left to fill the box. 13 in there. That's exactly the same calculation. They make 12 just as they made 12, because that's the same as that. Right, let's just get this somewhere else. Surely something else is available. One of those is 6. Okay, that's important because one of those is 6. So the 6 in column 7 is there. Right, that surely gets us going. Oh no, that 8 has been looking at that for ages, and that really does matter. Now these can add up to 7, so they must be 1 and 6, which is much more helpful. That sorts out the 1 and 6 above. 9, 7. That figures out the top right corner. That does box 6. We're just left with boxes 7, 8 and 9 and 6. This is 3 here, 8 here and 2 here. Does that make 13? Yes, it does. Whew. So I've made heavy weather of the end of that, but frankly I'm happy enough with the solve at the start that I'm not bothered. Shall I colour in the remaining 7s and 6s? I'm sure you'd like to see the pattern completed. And if I miss one or colour one wrong, just shout at me. It's fine. Blue there and orange 4 and 9. There we go. And that, I think I got them all. That is a fantastic unlucky 13 Sudoku. Thank you very much to Listes or Listesh, or however you would like to pronounce that. Brilliant puzzle. I hope you did have a go at that. Really enjoyable. Now, what was the other rule set? I do not know. Let's have a look, actually. So, hard version, as we did it. Easy version. Additionally, in both row 1 and column 1, the sum of the numbers outside the killer cages is 13. So 1, 3, 7 and 2 is 13. 1, 7, 2 and 3. Same sum is 13. Yes, that would have helped quite a lot to know that those actually, yeah, that would give us this number straight away, wouldn't it? Which must help. And down here, not so helpful. It would, no, it wouldn't be so helpful in the column, but at least you'd get a 6 to start with there, which could really speed things up. I don't know if you'd still need the colouring mechanism, which I do feel was, if not necessary, at least extremely helpful in this puzzle. But what a wonderful puzzle, really enjoyable. Thank you very much, and thanks for watching. Hope to see you soon on the channel. Bye for now.